Welcome to Bednik Tutors YouTube channel. In this channel, we will be breaking down topics of each science subject in order for you to have a better understanding of each topics. Because as a teacher, we believe that every student should understand fully every topics they are being taught. So, in order not to miss out on any of our videos, because all the videos we'll be uploading are very important, please do well to subscribe to our YouTube channel. Also, like and share. We also have a Telegram channel where you can communicate with us, ask questions and meet with other educators. The link of our Telegram channel is in our YouTube bio and comment section. Now, say these after me. I understand mathematics. I understand physics. I understand chemistry. I understand further math. That is a spirit. Bednik Tutors. Excellence is our watchword.
That a train starts from rest, accelerates uniformly at the rate of 2 meters per second until it attains a maximum velocity in 20 seconds. It maintains this velocity for 60 seconds and then retards uniformly to rest after a further 20 seconds. So we are told to draw a velocity time graph, draw a graph for the motion, use the graph to determine the maximum velocity reached, the retardation and the distance covered. So we want to look at here. We will say a train starts from rest. So if a train is starting from rest, so in our solution here, if a train is starting from rest, that means the initial velocity for the first stage, we refer to this as first stage. For the first stage, our initial velocity is 0 meters per second. Then our acceleration, A1, is 2 meters per second square. 2 meters per second square. Meter per second square. So then, until it attains a maximum velocity in 20 seconds. So the change in time, which is our T0 minus T1, change in time, which is our T1 minus T0, will be 20 minus 0, which is 20.0 seconds, or 20.0 seconds. That's our change in time, 0.0 seconds. So that's the 20 seconds. So you maintain this velocity for 60 seconds. So since we talk about maintaining this need for 60 seconds, so we have our second stage. So we can say from here our second stage. Before we get our second stage, we've not gotten our final velocity. So from here, our final velocity is not gotten. But how do we get final velocity? We have to start with the equation of motion for v is equal to u plus at. So this will be u1, v1, a1, and this will just be my change in t. So my v1 will now be my u1, which is 0 plus a, that's 2 times 20. So from here I now say my v1 is equal to 0 plus 40, which is 40 meter per seconds. That's 40 meter per seconds. So through that we know that my v1 is 40 meter per seconds. That's settled. So let's move to the second stage. For the second stage of our motion, if you note this, our v1 is also the initial velocity of that second stage, because the vehicle will not start afresh. So our v1 is the initial velocity. So we have to look for v2. Okay, v2, since it's the maintain that speed, so v2 will also be 40 meters per second, because it maintained the speed. They said it maintained this velocity for 60 seconds. So since there's a maintenance of velocity, so it will be for 40 meter per second. Please take note of this. Take note of this. The initial velocity, the final velocity of the first stage in motion will always be the initial velocity of the second stage. The final velocity of the first stage will be the initial velocity of the second stage. Then since there's no acceleration in that second stage, they said it maintains this velocity for 60 seconds. That means the final velocity will still remain 40 meters per second. Since the acceleration does not change, the acceleration still remain constant. Automatically the velocity will remain constant. It's the change in acceleration that brings about change in velocity, either increase or decrease. I'm sure that's clear to us. So to you guys. So V2 will still be 40 meters per second. It's just that my acceleration here, A2 is 0 meter per second square, it doesn't change. Then my change in time, which is my T2 minus T1, because we have the first time is 20. So here will just be 80 minus 20, which is 60 seconds. 60 seconds, yeah. Now said they maintain it. The 80, they said 60 seconds was added. So they added the 60 to the initial 20. So to make it 80 minus 20. That's 60 seconds there. Then they now said it then returned uniformly to rest after a further 20 seconds. So we said it will start uniformly to rest. So we'll move to the third stage. The third stage will now be, the third stage will be V2 is equal to U3, which is 40 meters per second. Then since it's brought to rest, so my V3 here automatically is 0 meters per second, because they said after a further 20 said and then retard uniformly to rest. Since it's being retarded uniformly to rest, it will be at, that is, the vehicle, the train is now going to stop. So the final velocity will be 0 meters per second. So automatically my time, change in time, will still be 20 seconds. So further 20 seconds. So that's that. So we want to draw here now. We want to draw the velocity time graph. Please read the question over again, because that is how to be able to understand all these things. So we want to draw the velocity time graph. We want to draw that. We've itemized our calculation. You will see the benefit of it now. We have our diagram here. This T second. That will be horizontal. The time is always on the horizontal axis. We have the vertical axis, velocity. So just as we said the vehicle starts from rest. This is 0, 0. That is 0 for vertical, which is velocity, 0 for the time, which is second. So they said a train accelerates uniformly for 20 seconds. So this is 20 seconds. It accelerates uniformly for 20 seconds. We have 20 here, 20 seconds, with an acceleration of 2 meters per second. So my A1 here is 2 meters per second square. So it now maintain this speed for another 60 seconds. So this will be added here. 60 here. We add 60 to this 20. That will make it 80. That's why we have 80 here. Just subtract to show our 60 there. Then we will now say it now brought to rest in the next 20 seconds, which make this 20 will be added to here. It will become 100. A train start from rest accelerate uniformly with an acceleration of 2 meters per second square. So that's why we did the whole calculation there, so that we can get the final velocity of 40. So we place this under 40 since we've calculated it down there already. Please try and take note of those stages. Since we've calculated it down there already, that's 40. Then it maintains this speed for 60 seconds before decelerating. So we know here that our initial velocity is 0 meter per second. Here is 40 meter per second. Here is still 40 meter per second. So here is 0 meter per second. This is my V1, is also my U2. While this is my V2, which is also my U2. While this is my V2. Please take note of that. V3. Let's take note of that. This is my U1, which is 0 meter per second. This is my V1, which is given as my initial velocity of the second stage. This is the first stage. This is my second stage. This is my third stage. So the starting stage, this is the acceleration stage. This is the state of constant velocity, whereby there is no major change in the velocity. So what we now need here now, majorly, is that in the question we're told to withdraw the velocity tangent. We're told to find the maximum velocity which show. The maximum velocity which has been calculated here as 40 meters per second. So that means the question is solved already. 40 meters per second. We just state maximum velocity reached is is 40 meters per second. 2. Then lastly, we're told to find, okay, second to the last, the retardation. So we want to calculate the retardation here. So permit me to clean this. Retardation. Retardation means deceleration. So it has to do with the second stage. So since we are solving graphically, we can do something here. Name this A, name this B, name this C, name this D, name this E, name this F. So let's deal with it like that there. So you can also after F then make this G, that is for the time there. So yeah, for this retardation here, normally retardation is final velocity minus initial velocity over final time, maybe like this is t0, t1, t2, t3. So we can say t3 minus t2. So from here we solve it graphically now. This d, so d minus c over, that's final velocity, then same d again we use for time. So say d minus e. So the d is standing for both time, both velocity and the time there. So here will now be my retardation, that will be d minus a, that will be 0 minus 40 over 100 0 minus 40 over 100 minus 80, and that will be minus 40 over 20. So my how is equal to minus 2.0 meter per second square. So retardation is 2.0 meter per second square. That's for retardation. Then retardation means negative acceleration. That we just remove the negative out of it there. That's our retardation. We are now told to find the distance covered. Don't find the total. Here now is the total distance covered. So we want to look at the total distance covered. So in looking at the total distance covered, look at the whole graph. Look at the whole graph. In looking at the whole graph, you realize that this whole graph, the graph AD, has a trapezium nature. So for the trapezium, we have a total. This will be the longer length. We make this one A. This is the shorter length B. The number. This will be our height. This is our height. So for the 3, for the total distance covered, for the total distance covered, we can also from here. For the total distance covered, we can now say from here is equal to TDT, total distance covered, that's TDT is equal to half, open bracket, then the longer length is AD plus the shorter length is BC. After that is done, then sorry, and the height is BF. The longer length is okay, let's say AD, let's make it AD. The shorter length BC, you can also make it FE is allowed. Then the height can be BF or CE. So I make use of BF here. So from there I can now say my TDT is equal to half, open bracket, the total length here, that's 100 seconds, plus the shorter one there is 60. My height is 40. So that would be half times 160 times 140 times 40 rather, over 1 over 1. 2 here 1, 2 here 20. So 160 times 20, that should give us 3,200 meter. So that's all. Very simple. Just look at the question again. After you've checked the question again, read it and solve it yourself. Very simple. Let us we follow that. And I've told you, if any question on velocity time you have in Y or NECO, it will always be in the patterns like that. So please try as much as possible to do that. Let's move to the second question. Thank you for following us.